Garbage collection is one of the most important concerns as it has various effects on the society. If the garbage is accumulated for a long period of time, it can lead to many issues such as waterlogging, rotten smell, and this further leads to various diseases in the corresponding area. Another issue is that many people tend to keep garbage outside the garbage bins rather than putting it into the bins in order to prevent their hands getting dirty, as the bin is dirty or it is surrounded by a large number of germs. To solve this problem, we have created this system which will automatically open the lid of the bin when user wants to throw garbage into the dustbin. It will notify the concerned staff when the dustbin is full so that they can collect the garbage from time to time to avoid its accumulation. We are using Arduino Uno, 3 LEDs, ultrasonic sensors, resistors, servo motor, Wi-Fi module, breadboard and wires for the connection purpose. So this is our simulation part. When we are changing the distance, the first ultrasonic sensor here is used to measure the distance between the object and the bin. Look at the two values that are being printed on the serial monitor. First reading is for the first ultrasonic sensor, and you can see that if the object is at the distance of more than 50 centimeter, the lead will stay closed. You can also see the servo motor at 0 degree in this case. And when the object is at the distance of 50 centimeter or less than 50 centimeter, the servo motor is being rotated at 90 degrees, and this will be used to open the lid of the bin. We have used another ultrasonic sensor for measuring the distance between the garbage and the lid. So yellow LED will blink when the distance between the garbage and the lid is between 50 centimeter to 200 centimeter, and red LED will blink when the distance between the lid and the garbage is less than 50 centimeters, which will then notify user using the Wi-Fi module. We have used Firebase to store the threshold value. You can see that we can store the garbage level value in the Firebase. We are changing the threshold value from 150 to 170, and you can see that the change is being reflected in the Firebase as well. Thank you.
Hello all. This is a demo video to demonstrate our Internet of Everything project. Our topic is home automation system and the details of the team members can be seen here. So let's get started with the demo. Our system consists of a home gateway. All the components are connected to the home gateway wirelessly. The user's smartphone can be used to control all the home gadgets remotely. As you can see in the IoT monitor, all the components are listed. The conditions are also mentioned according to what sensor reading what will be the action of the actuators. For example, when the door will be unlocked, when the security cam will turn on, etc. Now let us see all the components one by one. This is the water level monitor, which is used to monitor the level of water, and it displays the readings in centimeters. When the water level is greater than 21 centimeters, the lawn water sprinklers are turned off to prevent oversaturation of water in the lawn. When the water level drops below 2 centimeters, the lawn water sprinklers automatically turn on to prevent the lawn from drying out. On the roof of the house, a solar panel is installed. In the daytime, solar energy is collected and stored in the battery, which can be used when there is no power supply in the house. In this way, we can make use of renewable sources of energy and benefit the environment. The garage door is opened automatically when the carbon monoxide level crosses the threshold value of 0.02% and there is some motion detected. You can see both conditions needs to be satisfied. In this way the system works efficiently. In case one condition is not satisfied, the door closes. This is the webcam. The main door opens according to the RFID reader. We can see when an invalid RFID card is brought in front of the RFID reader, it blinks a red light and the main door remains locked and the security webcam is turned on to prevent any kind of security breach. When a valid RFID card is brought in front of the RFID reader, it blinks a green light and the main door is unlocked and opened. The security webcam installed at the front door is turned on to monitor who is entering the house. Now, let us go inside the house. As you can see, there is a microcontroller board and some components like the fire alarm, the LCD screen, the fire sensor, and the fire sprinkler are connected to it. The LCD is used to display what is the status of the actuators. When fire is sensed by the fire sensor, the fire sprinkler and fire alarm are turned on. The state of the actuators is changed and the LCD board displays the changed state. This fire control mechanism is very important in a home automation system as it helps to save lives from fire hazards. Now, let's move to the balcony area. As you can see, in the balcony a smart door is installed along with a smart lamp. At first the balcony door is closed and the smart lamp is also off. When motion is detected by the motion sensor that is present near the balcony door, the doors open automatically and even the smart lamp is turned on. After a delay of 30 seconds when no motion is sensed near the door is closed and the lamp is turned off. In this way, the power consumption of the house is also reduced. The LCD also displays the message according to the condition of the light and door. Now, let us see the temperature control mechanism of this home automation system. These values are hypothetical values as it is software-based simulation. Now, the temperature displayed on the temperature monitor is around 7 degrees Celsius. According to the temperature, the AC, window, and the fan is being controlled. As you can see, when the temperature crosses 8 degrees Celsius, the bedroom window is closed and AC is automatically turned on. The fan present in the living room is also turned on high speed. The cooling process of the AC begins and it decreases the temperature of the house. When the temperature has dropped to 3 degrees Celsius, that means the temperature of the house is cool enough, the AC and fan are turned off and the smart window is opened. This is the end of our project demonstration. Thank you for watching. We are using the Kuja simulator in Contiki OS and we have added the modes onto the grid. The middle mode is the border router and the surrounding modes are the sensors, carbon monoxide gas, temperature, humidity and pressure are near the router. Once we start the simulator and start the router from the terminal, the data transmission process begins. As you can see, the router is up and running now, and the output will be displayed on the web browser. We add the IP address of the router and find out the neighbors, that is the sensors, and we will access one neighbor to find out the sensor values. Hence, we successfully gather the sensor values from the simulation, which can be very beneficial. Now, we will see the MQTT protocol using the same Kuja simulator. We add the border router here as well, including the subscriber and publisher modes of the MQTT protocol. Once they are in vicinity to each other, we start the server and open the terminal to begin the router. Once the router is running, we then open another terminal to begin the MQTT broker and client process for the simulation. Now, the MQTT protocol has started listening for the data transfer, so, we go into the Kuja simulator and start the simulation for the protocol to be seen in action. We can see the data transfer occurring live through the arrows on the grid, and the data been transferred in the logs. Thank you.
It consists of various components like rain sensor, DHT11 sensor, BMP 180, which is the pressure monitoring system sensor, and Arduino Uno as the microprocessor. This project is made on Proteus simulator, and I will just start with the simulation. When I run the simulation, it presents a welcome message, and it mentions the sensors that are connected to it. And it will show the readings of the sensors. Currently, it is the first reading, so it is 0.00. Now, in the second reading, we can see if it's reading or not. So, since it is a Proteus simulator, it has a toggle key where when it is 0, it shows no rain. But when you toggle it to 1, it should show raining. As you can see, temperature, humidity, and temperature are again shown by both the sensors, and it's reading as we have toggled the. We can also change the values of temperatures using this sensor simulator. So when we change this to 90, we change this data to 27, 28 degree or 30 degrees. We can also toggle the pressure monitoring system here, and the temperature changes here. We can see 25, 90 degrees and 25 degrees. Now it's 31 degrees, 90 degrees. We'll just turn off the rain. And it's this new rain. So the Proteus simulator is working fine, and this is the basic simulation of a project.